Hello everyone, welcome to today's section. In this session, I am going to explain about the topic relational model concept and relational model constraint, which comes under subject database management system. So let's begin. Here is an overview of the relational model. The relational model is the foundation of modern database systems, providing a structured and efficient way to organize and manage data. It allows data to be stored in tables with relationship defined between the tables. This provides flexibility and ease of access for querying and manipulating data. Next, next is definition of relational models in various terms. Structured data organization. The relational model is a method of structuring data using tables, with each table representing an entity and the columns representing attributes of that entity. This structured approach allows for easy storage and retrieval of vast amounts of data. That is, structured organization is nothing but how the data is stored. It is in the form of a table with rows and columns. Rows represent as a tuple and each column represent as an attribute. Next is data integrity. One of the key aspects of the relational model is maintaining data integrity. This means that the data entered into the table accurately reflects the real world entities being represented, ensuring consistency and accuracy. Data integrity, this is nothing but what the values entered in the table, it reflects the real world uh, values. Next is query and manipulation. Using the relational model, users can perform complex queries to retrieve specific set of data and manipulate the data to generate meaningful insights, making it a powerful tool for data analysis. This means we can perform the queries on the table so that we can retrieve a particular set of data from the table. Next is basic components of a relational model. Tables. The tables are the basic building blocks of the relational model, representing entities and their attributes. Each row in a table represents a specific instance of that entity. Next is attributes. Attributes are the properties of the entities being represented in the tables. They define the characteristics of or features of the entities. Next is relationships. Relationships establish connections between different tables, allowing for the representation of complex real-world scenarios in, in the database. Now let's see the key concepts of relational model. Data normalization. Data normalization is a key concept in the relational model, involving the process of efficiently organizing data to reduce redundancy and improve data integrity. Next is relational algebra. Relational algebra forms the basis for manipulating and retrieving data from the relational databases using a set of operators. Next key concept is acid properties. Acid is, in a sense, atomicity, consistency, isolation, durability. These properties ensure reliable database transactions and are fundamental to the relational model. Next is relational model constraints. Let's see the overview. The concept of constraint is fundamental to maintaining the integrity and reliability of stored data. Constraints act as rules or conditions that govern the permissible values and relationships within tables, ensuring that the database remains accurate, consistent, and adheres to its defined structure. That is, constraints are nothing but the rules what is given to the particular attribute, whether it is a primary or a foreign key or it is represents to the other key of the table, that is foreign key. Purpose of constraints: data integrity and consistency. Data integrity in a sense, constraints are essential for safeguarding the accuracy and reliability of data stored in relational database. Consistency: they enforce rules that maintain the consistency of relationship between tables, preventing anomalies or conflicting information. Now let's see the various constraints applied to the attributes. Here is mentioned is a primary key constraint. The purpose of this constraint is it ensures uniqueness and identifies each record uniquely in a table. There cannot be a two primary key in a table. Implementation: a column or a set of columns is designated as the primary key. No rows can have the same primary value and it cannot contain null values. So a primary key it must and should have the values. It cannot be a null. Next is foreign key constraint. The purpose of this constraint is it establishes relationship between tables, ensuring referential integrity. This referential key constraint is used to represent that this attribute is referring to the another attribute, that is the primary attribute of the another table. Implementation: a foreign key is one in one table refers to the primary key in another table. This constraint ensures that values in the foreign key column must match values in the referenced primary key column. That is, the attribute which is mentioned as foreign key, it should match the values with the uh, primary key to which it is referenced in another table. Next is referential integrity of maintaining relationships. The main purpose of this referential integrity is maintaining the relationships. Referential integrity ensures that relationships between tables are maintained, preventing inconsistency and preserving data accuracy. Next is entity integrity constraint. Entity in a sense you're identifying uniquely. Like it is an entity to identify that this is unique. One thing is, and the another thing is data consistency. Each uniqueness is applied. Each record in the table is uniquely identified through primary key, ensuring entity integrity. Data consistency, how it can be applied. It ensures that primary key columns does not contain any null values, maintaining data consistency. This is how the entity integrity rule is applied on the table. Next is domain constraint. The rules of this domain constraint are data validity and data integrity. Domain constraint defines the allowable data values for a specific column, ensuring data validity and accuracy. So, in a table, the attributes are given with a domain value. For example, a name attribute containing a var with 15 domain value. It means that a name attribute can have only up to 15 characters only. If it exceeds more than 15 characters, it will not accept. Next is data integrity. They prevent the insertion of invalid or inappropriate data into the database, maintaining data integrity. For this, you can give the example as uh, attribute having a varchar cannot take the values of integer values. Now let's see one of the database schema. Here I mentioned the company database which has employee, department location, project, works on, dependent as the tables, that is the relations. In each table there are the attributes. Here in employee table, first name, middle name, last name, SSN. These all mentioned as the attributes. In employee, SSN is the primary key. In department number is the primary key. In department location is the primary key. In project table, project number is the primary key. In works on table, employee SSN, it is a foreign key. It refers to the employee table. Next is dependent table. In this also employee SSN. It's also referring to the employee table, which is this employee ESSN. Independent is mentioned as foreign key. The arrows which is mentioned in this diagram is represent as the referential integrity. In conclusion, the utilization of relational model constraint is paramount in the realm of database management. These constraints, ranging from primary keys to referential integrity, collectively contribute to the foundation and reliability of relational database. As we have explored, this purpose extends beyond mere rules. They act as custodians of data integrity, ensuring accuracy, consistency, and coherence within the database structure. In the dynamic landscape of data management, the concise integration of relational model constraints remains an enduring principle, ensuring that database involves as independent or dependent, coherent, and resilient repository of knowledge. So this was all about the relational model concepts and the constraints, that is the rules applied to the table. Thank you.